This is CS1101, lecture 3.3. Today we're going to be going over the IntelliJ IDE, as well as continuing our discussion of decision statements. The general process for setting up the IntelliJ Studio is set up a project, set up the module. Now we're only going to set up one project for this course. All your programs will be kept in a single project. Each assignment will be kept in a separate module, and then for each of the components of a specific assignment, you will have a Java class. Then you'll code your program, compile it, and test the program, and you will debug until the program is correct or until you lose your mind, whichever occurs first. And that'll be the general process for using IntelliJ, but also for the rest of this class. So let's begin by installing IntelliJ on a computer. These instructions are available on Brightspace, and you should use them to install IntelliJ on your computer as well. So the first thing to keep in mind is that if you have a previously installed version of Java on your computer, you should remove any old versions of the Oracle JDK. So first of all, after that, download the Community Edition of IntelliJ IDE. One adjustment to be made to the instruction sheet here. So the instruction sheet references that the current version of IntelliJ IDE is 2019.2. The current version is now 2020.1. Further, the JDK that comes with it is no longer version 11, but it is version 14. Use the default JDK, which is downloaded with the IntelliJ IDE environment. So there's also the Ultimate Edition, but it is unnecessary, and you will have to deal with having a trial instead of an actual full-fledged version. The community version is fully open source and freely available, and it'll do everything we need it to do. At this point, we have downloaded the IntelliJ IDE, and we need to move forward with installation. So when you're installing the IntelliJ IDE, make sure you use the defaults that are suggested. Don't import any of the previous settings. And also make sure you check the box to create an association with Java file extensions. After downloading and installing IntelliJ, it's time to launch for the first time and create the project. So we're going to launch and then need to tune IDE for specific tasks we're going to use it for in this class. And we have to make sure that the plugins option is enabled. So do not import settings. I like the dark mode. Either will be fine. So here we see the plugin development is already enabled by default. So at this point, we're ready to create a project to house all the programs for this course. So you will choose Create New Project. For whatever reason, that seems to take a moment. So here you'll see the document, as I mentioned earlier, references version 11. However, IntelliJ now comes with version 14, which is fine. We will use version 14 instead. So here you see version 14. and this is the version that we will use in this class. So we'll name this project CS1101 because it's going to house all the programming assignments we do in the course. So at this point we need to add a module. So the instructions for adding a module are shown here, and continue down. If you need to reference them, they're in the document. So you can highlight folders and then select the command to add a new folder. Oh yeah, IntelliJ always shows these tips, so you can keep them or not. But I like to right click and add new module. So the name for this module is going to be Programming Assignment Beta, PA Beta, and it's going to use version 14 just as the rest of the project will. Now we need to add a class to our module. So notice in the instructions it's going to point out that we need to be careful about where to put the class. Don't put it in the source folder for the project. We need to put it in the source folder for the module. There's even a statement that says warning. So make sure to get that right. Don't put the class in the wrong source folder. So the source folder highlighted here is the incorrect source folder to use. This is the source folder for the project in general. Rather, we need the source folder which is inside the PA Beta module folder. This is the correct source folder to use. So we'll right click and we'll insert a new Java class. This class name is going to be Hello World. A class is always going to have the file extension .java, so you don't actually have to type hello world.java, you can just type hello world. So now inside of our source folder we have hello world. So now we're going to create a small program and run the program, which will print hello world to the console. So the source code is opened in the right hand side. This is the IDE environment where we will edit and write code. So we've created a method, public static void main, and this is just part of a recitation. Don't worry about what it means at the moment, but we include the parameter args, and then it's going to be one statement long, so we're only going to use a single statement in this main method. System.out.println, not println, print line, and we are going to pass it a string, literal, which is hello world exclamation mark. We end it with a semicolon. Then I'm going to put a comment to tell what this does. This will print hello world to the console. So there are instructions to run the program in the IntelliJ overview document. To do so, we are going to select the run option from the menu above. And then we'll select the hello world program from the pop-up. So run. And then we'll select hello world. So now it's building it, which is compiling. And then the console pops up, and we have our output, hello world. At this point, we have successfully downloaded IntelliJ, installed it, and created the project for the class, added a module for our programming assignment beta, and added a class, which would be the Hello World class, and we have written a program which will display Hello World to the console, compiled and run it successfully. As we move forward with programming assignments, the IDE built into Zybooks will become less and less convenient as the programming assignments get more complex. The number of times that you're going to want to test the code is going to go up significantly, and it's going to be much more convenient to develop and test your programs in an IDE on your own machine. So at this point, I would recommend you begin to develop all your programming assignments in the IntelliJ IDE environment, and then you can copy and paste the code into the Zybooks environment for final testing and submission. At this point, let's continue with our discussion of conditional statements or decision logic. So in the example here, we have an if statement which is mutually exclusive. So only one of the available paths will be executed, and we have used an else statement which guarantees that at least one path of this if statement will be executed. Because if both of the available tests fail, then we will execute the else. On the right-hand side, we see the flowchart that also represents this type of if structure, and it's clear that there is no path forward that does not involve a set of actions. So coming into the first decision, either path, if it is true, then we will have a set of actions to take. If it is not true, then we encounter another decision. If this decision is true, we will encounter actions to take. And if the second decision is not true, then we will also encounter actions to take. So it's immediately apparent that it's impossible to escape this if statement without taking one of the available sets of actions. The other thing that's apparent is there's no possible way to execute more than one set of actions. So if the first decision is true, then we take the actions that are associated and we exit the if structure. However, if this test fails, we go to the second test. If this test is true, we take the associated set of actions and exit the if structure. If this test is not true, we take the associated set of actions and exit the if structure. So there is exactly one path. Not zero, not multiple, exactly one. If we were to remove the else statement at the end of the previous structure, we would wind up with an if structure which has exactly zero or one path, which will be true. So in this particular case, you can see that if the first test is true, then we have a set of actions to take. If not, we have a second test. If this test is true, then we have a set of actions to take. So forth, we have a third test. If this test is true, we have a set of actions to take. However, if all three tests fail, then we take no actions and move forward. In both situations, there is no possible way to have multiple sets of actions occur. They are mutually exclusive. However, in this particular structure, 0 or 1 set of actions will occur. In the previous set of actions, exactly 1 set of actions would occur. By set of actions, I mean a group of statements. So here we encounter statement 1, statement 2, statement 3. So I was referring to a statement as an action or a set of actions. So in the previous two if structures, we could not have multiple paths occur. We would not ever have a situation where multiple actions would occur, multiple statements would be executed. It was always 0 or 1. Well, in this if structure, we can have 0, 1, or multiple paths which are true, and therefore actions which are taken. So each of these if statements is independent. Therefore, this test will occur, and if the Boolean expression evaluates to true inside the test, we will execute the statements inside the curly braces following the if statement. However, if it is not true, then we will the program pointer will jump to the terminating curly brace and move to the following statement, which is another if. So each of these if statements is independent. Each one will be independently evaluated, and the statements will be executed simply based on the test located in parentheses after the if statement. So each of these tests will be evaluated, and the statements will be executed based on whether or not that test evaluates to true. So we could wind up executing all three of these, one of these, two of these, or none of these. And that is mirrored and more evident in the flowchart to the right. So on our first decision, if this test is true, we will execute the associated statements. However, if the test is not true, then we will not execute the statement. But either way, the program pointer is going to wind up in the same place. We're going to wind up going into the next conditional test. And we are going to test if test 2 is true. We're going to check and see if test 2 is true. If it is, we will execute the associated statements. If it's not, we will not execute the associated statements. Either way, we are going to evaluate test 3 as well. And if it is true, we will execute those statements in statement 3. So in this way, we could wind up following all the no paths, in which case we don't execute any of these statements, and in this case, none of the paths are true. However, we could also wind up executing all of them. So in this case, we could have 0, 1, or multiple paths, and therefore a set of statements be executed. Sometimes it is appropriate to use independent decision statements. For instance, if we were deciding on what sort of pizza that a customer wanted, we could have the test user wants heart-shaped pizza. So this is a Boolean expression, a conditional evaluation. And if it's true that the user wants heart-shaped pizza, then we will add special Valentine's Day upcharge to the cost. So this is the situation where we are computing the cost of a pizza. If a user wants heart-shaped pepperoni on pizza, then we would add a special pepperoni charge to cost. So notice here, just because they want heart-shaped pizza doesn't necessarily mean that they also want heart-shaped pepperoni. So these are independent. So it shouldn't be a situation where choosing heart-shaped pizza means you can't choose heart-shaped pepperoni, and it shouldn't be a situation where not choosing heart-shaped pizza means you do choose heart-shaped pepperoni. So they are independent in nature, and therefore they need to be evaluated independently in independent if statements. Similarly, we can have an independent if statement following that tests if they want green M&Ms on the pizza, which is also independent of whether they want heart-shaped pepperoni. And then finally, if the user wants delivery or not is also independent. So it's appropriate in this situation where you're testing, where you have this set of tests, it's appropriate to use independent if statements. So in the previous example, it would have been inappropriate for us to use an if, else if statement, because this would have been mutually exclusive. We would only have been able to choose one of the available options. We needed something that allowed for independent if statements, so it was sort of an if structure. It's important whenever you come to a situation in programming to be able to identify which type of if structure you should choose to accomplish the functionality you intend. Choosing the right structure for conditional logic can be confusing at times. But one simple way to think about the underlying question is, are you choosing a type of shipping for something that you've bought, or are you choosing toppings on a pizza? So what I mean by that is, are you in a situation where you must choose one of a set of options? So like choosing a type of shipping. If you buy something on eBay, you have to choose a way to ship it to your house. And you can't choose multiple ways to ship it to your house. You have to choose exactly one. However, if I'm choosing toppings for pizza, I can choose one topping, two topping, as many toppings as I want, or no topping. So in the pizza topping situation, what we're really dealing with is selecting independent options. So the selection of tomatoes on the pizza does not necessarily have any effect on my selection of the type of cheese I want used. So in this situation, we want to use just if statements, individual if statements, which are independent from each other. However, in the shipping method situation, where we're needing to choose precisely one option, we should use an if-else, because we need to choose precisely one of many options. So here's a practice question. If we were going to print whether a number is even or odd, which of the available if structures, if-else, independent if, which is number 2, if, multi-if-else, or multi-if-else-if, the difference between 3 and 4 being that in 3 we are going to terminate with an else, and in 4 there is not an else. Which of these would we use to display a message for a number being even or odd? Well, it would be easiest, most likely, to come up with a logical test to find out if a number is even, and then there's only one other option. If the number is not even, it must be odd. So we can use a simple if-else. So option 1. So in our test, we are just going to mod by 2 and see if the result is 0. This is a simple way to test if a number is even. So in this case, we will do a print line statement, and we will print the word even to the console. If it's not even, then it must be odd. So this is a situation where we have exactly one result. The number must be either even or odd. There's no in between, so there's no option for there's not a no path chosen option, and there's no way to choose both. So we need to choose exactly one of either even or odd. Can't choose neither, and we can't choose both. In which case, if-else makes the most sense. Now consider a situation in which we need to, for tax purposes, decide whether or not a user belongs in a particular lower tax class, middle tax class, or upper tax class based on their income. Which type of conditional logic structure would we choose to do this operation, to print the appropriate output to the console? Well, in this situation, there is exactly 3 options: lower class, middle class, and upper class. So there's no situation where we can have none of these selected. So that limits the options. And then there's also not a situation where a person can belong in both the lower class and the middle class, or middle class and the upper class. So there's no situation where we can have multiple selections. So we are again in a situation with exactly one result. So that tells us that we need to have an else statement, because we need to have certainty that we will execute one of the paths, and we need to have mutual exclusivity. So we need to have it so that not more than one option can be selected. That gives us only one valid selection. That would be a multi-if-else. So we will have, if income is greater than 8, then they are upper class. If income is greater than 5, then they are middle class. And in all other situations, the person must be lower class. So in this situation, we are reading a number in from the user, and we are going to print messages to tell whether or not the number is divisible by 2, 3, or 5. And it is important to consider a number such as 30 in your thinking about the situation. So which conditional structure would we use? If-else, independent if, multi-if-else, or multi-if-else-if? Well, first of all, the question we need to ask ourselves is this a shipping method situation, or is this a toppings on a pizza situation? To answer that, are these independent, or are they mutually dependent? Is it possible for a number to be divisible by none of these? Yes, that is possible. Is it possible for a number to be divisible by more than one of these numbers? Yes, 30 is an example of a number which would be divisible by all three of those numbers. Okay, so we have a situation where we can have a group of these selections, none of the selections, or 1. So we can have 0, 1, or many of the 2, 3, and 5 options. In this case, we definitely need to use independent if statements. So option 2, if, because there is no mutual dependence. So it's not a situation where we can say the number is not divisible by 2 and not divisible by 3, therefore it is divisible by 5. That doesn't work. So we need to test to see if the number is divisible by 2, and then we'll print a message based on that. We need to test if the number is divisible by 3, print a message, and then independently test if it's divisible by 5 and display a message for that as well. So that's exactly what we have here in code. We test for the number being divisible by 2, which is equivalent to being even, right? And we print a message. Completely independent from that result, we're going to have a separate test which has no relationship to the test for divisibility by 2 other than the fact that these are in sequence. So the divisibility by 2 will happen first, then the divisibility by 3. However, the results of this test has no bearing on whether or not this test occurs, which is different from an if-else if. Right? So we're going to do a mod command to test for divisibility by 3. And if it is divisible by 3, we'll print the message. Same thing we'll do with divisibility by 5. So these are independent. The result of this test, whether it's true or false, will not affect whether or not the number will be tested for divisibility by 3. And the result of these two tests have no bearing on whether or not the number will be tested for divisibility by 5. Each of these tests will be carried out in succession, regardless of the result of a previous test. And 0, 1, or many of these 3 may be true. So any combination of these tests may ultimately be true. So in this situation, we're going to read a user's GPA. So we're going to get their GPA from the user. And then we're going to print whether the student is on the dean's list or the honor roll. So notice, immediately, we have mutual exclusivity. If the student is in the dean's list, they are not in the honor roll. If the student is in the honor roll, they're not in the dean's list. And there's an option where they're in neither the honor roll or the dean's list. Right? Because 3.7 would not fall into either of these categories. However, that's not true. 3.7 would fall into the honor roll category. 3.4 would not fall into either of these categories. However, 3.7 would fall into the honor roll category, and 3.9 would fall into the dean's list category. Sometimes it's easiest to go about deciding which conditional structure to use based on samples like that. So if you can think of a sample to exemplify the situation, then that helps sometimes make it more concrete. You know, thinking about 3.4 shows that 3.4 would neither be a dean's list or honor roll student, so therefore we need to have a 0 or 1 number of true paths, because we can't be in the dean's list and the honor roll. That means these are mutually dependent. So we need to have mutual exclusivity. If you're in the dean's list, you're not in the honor roll, as I previously said. However, we also need to have the situation where it's possible to not be in either. So this is a 0 or 1 of the tests will be true. So to provide a 0 or 1 number of tests which is true, we would use a multi-branch if-else-if. Notice, not an if-else as in number 3, but an if-else-if as in number 4. So the big difference here, obviously, using number 4, there is no terminating else statement, which means that we can we can have none of the above tests be true. So then there's two ways of going about this. We can test for being in the range of 3.8, greater than or equal to 3.8, while being less than or equal to 4.0, and that be the way to test for Dean's List. And then we can do else if the GPA is greater than or equal to 3.5 and less than 3.8, then we know that you're in the honor roll. Or another way to go about this same test would be to test if the GPA is greater than or equal to 3.8, and then print out Dean's List, and then we can test if the GPA is greater than or equal to 3.5. So in this case, which would you consider better, and why? Well, both of these will work. However, in the second example, we are relying on the order of the tests to achieve the functionality. Imagine if someone made the mistake of testing to see if the student was greater than 3.5 before testing to see if they were greater than or equal to 3.8. Well, then it would always print out honor roll as long as they were in either category. So this test I find to be a little bit troubling because someone down the road may not completely understand exactly how this test works, and that they are relying on the specific order of these tests to achieve the functionality, and therefore in the future someone may come behind you and accidentally break this functionality. The top version is much more communicative. Just by looking at this and reading it, I can tell exactly what's happening. If it's in the range 3.8 to 4.0, we want to print this message. If it's in the range 3.5 to 3.8, we want to print this message. It's very easy to tell what's happening, and it's much more transparent, and I would argue more maintainable because of that transparency. Now consider a situation in which you're trying to print the grade A, B, C, D, or F based on percentage out of 10 points. Which of these would you use? If else, independent if, multi if else, or multi if else if? Well, I would go with a multi if else. The reason is this is definitely a shipping method situation. Everyone will fall into one of these categories, but they will only fall into exactly one. So there's no option for 0 categories to be chosen. So you have to be in one of these categories, A, B, C, D, or F. Everyone falls into one of those categories that gets a grade. Also, there's no option to be in multiple of the categories. So we will have exactly one of the tests succeed. So the way that I would set this up is I would test for A, B, C, and D. And if all of these tests fail, then we will print out that the person received an F if all of these tests fail. So what I'm saying is the printout for F will be in the else statement. So let's look at the code. So we have a test for if the grade was between 90 and 100, between 80 and 90, 70 and 80, 60 and 70, and then we have in the else statement a printout for they received F. So understand how this executes. If the test, which occurs first, is true, then we will print out the statement, this A. It just shows the letter grade A. Then once the terminating curly brace is hit, the program pointer will jump down past the end of this conditional structure. However, if this test is false, then the program pointer will immediately jump to the next part of the conditional structure. In this case, it's the else if, and it will perform the next test. If this fails also, it will jump to the next test, and then jump to the next test. And then if all of the tests fail, it will jump to the else. Now it will execute the statements which are in the curly braces following the else, which will print out an F. And that's exactly what we said, right? If you didn't get an A, B, C, or D, then you must have gotten an F. So this is definitely a choose the shipping method. Everyone falls into one of these categories. They have to fall into exactly one of these categories. So therefore, it should use a multi-if-else. So it's easy for if-else or conditional statements to wind up unnecessarily large, and a way to address that issue is to factor the if statements, factor these conditional statements. Factoring is really, it's just a fancy term for using your brain. It's a fancy term for paying attention to the underlying functionality that you're trying to achieve. So here's a good example. Now, in this example, assume that the value of the variable a must be either 1, 2, or 3. So in the if statement that follows, we test to see if a is equal to 1, if a is equal to 2, and if it's equal to neither of those, then we use an else, because a must be 1, 2, or 3. So in the else, we assume that a must be equal to 3, and therefore we will assign x to 9. So understand the functionality here. Apparently, we didn't, no one told us what this does. There's no comment saying what this does, but we can deduce if a is equal to 1, x is equal to 3. If a is equal to 2, x is equal to 6. If a is equal to 3, x is equal to 9. So it's as if we're multiplying a times 3. Does that make sense? So if we multiply a times 3 while a is equal to 1, we get the result 3. A times 3 when a is equal to 2, we'll get the result 6. And a times 3 when a is equal to 3, we'll get the result 9. So once we realize what we're actually trying to do, we can factor that out and remove it all together, and we can simply have the we can simply write the expression x equals 3 times a, right? So now we have a much more compact and readable as well as transparent statement that achieves the same functionality. However, there was one little extra tidbit we had in here. In the case where a was equal to 2, we also were going to increment y. So we still need to have a conditional test for the situation where a is equal to 2. So both the left and right code are identical. However, the right code makes fewer assumptions because it doesn't require the value of a to be only 1, 2, or 3. But it also does not require a complex if statement to achieve the functionality. So it's less code, fewer statements, and it's more readable. So here's a further example of code that needs to be factored. So when factoring, the question that we're asking ourselves is what functionality is common or can be removed from the if statements and achieve the same functions. So specifically, let's look for functionality that shows up in each of these if statements. So redundancy, right? Well, our first statement in each of the if statements is you have however much money left. So again, in the next if statement, you have however much money left, and in the else, you have however much money left. So we're doing that every time. That is redundant. Similarly, we're asking how much do you want to bet every time, and then getting the next integer from the console when the user types it in every time. So that code is duplicated in each of the branches of this conditional structure. So that is entirely redundant. So what we could do is take this line and move it above the if statement, because it happens every time regardless. That allows us to delete this statement in each of the subsequent ifs, and it would also be deleted in the first. However, we're just showing it being moved. And then what we'll do is, after the conditional statement, we will move these two statements to below. And so these are deleted out of each of the other conditional branches. So now we should have just a single branch, or just a single statement inside of each branch. It should just be a matter of displaying the appropriate recommendation for how much money to bet. So here is a more cleanly coded version of the previous example, which we have factored. So we've removed the redundant functionality, the common functionality, which shows up in each of the branches of the if statement. So here we have our statement on how much money you have left. Then we have a conditional statement, which decides which betting recommendation we would give based on the amount of money left, and then we ask how much they want to bet. So some simple tips on recognizing when to factor code. Number one, if each branch starts the same, then move the start of the branch to before the if else. If each branch ends the same, then move it after the if else. That's exactly what we had to do in this example, right? We have moved this out of each branch to before the if statements, and we moved these statements below the conditional statements. If similar but different code exists in each branch, look for patterns. So that's sort of like the example from 2 slides back where we noticed that they were really just multiplying by 3. So you can look for patterns when similar code exists in each of the branches of the if statement. So here's a factoring mini exercise to practice your factoring skills. So go ahead and pause the video and attempt to solve this on your own before I show you the answer. So this is very similar to the previous factoring example we had. So notice in both the if statement and the else, we start by printing out x equals and the value of x. So we would be able to move the first statement to before the conditional structure. And then notice also that we always terminate with y equals and the value of y. So we will move this to after the conditional structure. So then both of these statements get deleted. So here's that code written up more cleanly. We have print line statement, x equals, and then the value of x. Then we have a conditional statement to test if x is less than 10. We will add 20 and store that value into y. If x is else, then we will add 5 to x and store that value into y. And then we end by printing y equals and the value of y. In this particular situation, we could have put the first print line statement after the if structure, but before the second print line statement. I'll leave it to you to figure out why, in this particular case, that would have been acceptable. We've seen in previous examples that some things may work, they may compile, and they may run, but that doesn't mean that they are a good way of going about achieving the functionality we wish to achieve. So we have a situation here where we want to print out x is negative if the number is negative, which is stored in x. Otherwise, if the number stored in x is greater than 0, greater than or equal to 0, we want to print out x is non-negative. And we have code here that achieves this functionality. But can you think of any ways that we can improve this code? The first thought that I have is we're testing to see if x is less than 0, but then we also are separately testing to see if x is greater than or equal to 0. This is a mutually exclusive situation. If x is less than 0, then it is not greater than or equal to 0. However, if x is not less than 0, then it is greater than or equal to 0. So this is a mutually exclusive situation. It's a shipping method kind of situation because we must choose one of these. One of these tests must be true. So therefore, it makes more sense to use an if-else rather than an if-else-if. And one of the reasons that this is actually better code is consider if we had incorrectly coded the second test for non-negativity. Then it would actually be possible for us to have a number that didn't print out negative or non-negative. It would print out neither of these. We don't want that to be a possibility. We want our code structure to reflect the underlying nature of the situation because we're less prone to errors if we code in that way. So a better version of the previous code would be if x is less than 0, printline statement x is negative, else printline statement x is non-negative. This is less redundant, so you're doing less redundant work by including a second test, but you're also writing code which is more reflective of the physical reality, and therefore you're less likely to have errors. So here's a bit of a comprehension check regarding if-else statements. Do the two examples, example 1 and example 2, do the same thing? Do they accomplish the same function? We have if, and then our test is A is greater than B, and then we have the statements enclosed in curly braces, and the first statement in those curly braces is an if to test if C is greater than D, and then based on the result of that test, if it is true, we will assign E the value which is stored in F. However, if it is not true, then there is no else, and we reach the end of the curly braces code section for the if statement, at which point the program pointer would jump to the end of the conditional structure. However, if this first if results in the test being false, then the program pointer will jump to the else and will execute the statements in the curly braces following the else statement, in which case G is assigned the value stored in H. Okay, evaluate the second option. If, and then we have our test, A is greater than B, so far so good, it's the same. If this test yields true, then we will move to the statement which immediately follows the if statement, which is a further if statement. This is syntactically correct, so the compiler won't have a problem with this. So we test if C is greater than D. If that also is true, then we will set E to the value which is stored in F. So we will assign E the value which is stored in F. Then we have an else statement. So are these two equal? On the surface of it, you may think yes. However, there's a problem. So on the left-hand side, we have our else is joined with the first if. And this is because the second if is enclosed in the curly braces which follow the first if. However, on the right, our else is going to connect with the most recent if. Remember, in Java, indentation does not have any significance to the compiler. So even though our else has the same indentation as the initial if, the else is going to associate with the most recent if, which in this case is here. So now our code is going to test if A is greater than B, and if it is not, the program pointer will jump to the end of the if block and continue on. But that's not what we intended at all in the first example. If the first test failed, we would jump to the else. So these two are not the same because we did not include curly braces to enclose all of the statements following the first if, and therefore we have misassociated our else. So to avoid the error we saw in the previous slide, it's important to remember that every else is going to pair or associate with the nearest unmatched if statement. When we code properly, our indentation should help make the program more readable and make it obvious which else goes with which if. However, if our indentation does not match what we actually have coded, the reality of what we've coded, then our indentation actually becomes a stumbling block, because the compiler is going to ignore the indentation since the indentation is meaningless to the compiler. And programmatically, we are going to have a function that doesn't match what our indentation is communicating. And that's exactly what we just saw. The indentation seemed to show that the else would associate with the correct if, but that was not the case at all. A greater lesson to learn from this is to always use curly braces. Don't use the feature built into Java where you don't have to have curly braces if you only have a single statement for a given if or else. Don't use it. Be able to read it, understand that is an option that some programmers may use, and be able to read code that uses that type of functionality. However, don't make use of it yourself. Always use curly braces, and your code will be more readable and more maintainable. So one of the key uses of if-else branching or conditional structures in a program is to return different values. So remember, the return statement is going to cause a method to jump back to the calling statement immediately. So anything past that return is going to remain unexecuted. So for Java to compile, you have to have all possible code paths reach a return statement if you have declared the method to have a return value. So all paths must return a value of the correct type as well. As a rule, it is acceptable to have multiple return points. However, it is necessary that you comment your code well and make it absolutely clear what the code does. So here's an example of code that uses if-else branching to return different values, and we have multiple return statements, but we are following the rules which we have just set. So we are going to return a value in every possible path, and we're going to make it absolutely clear what the code does, and also we are going to return a value of the proper data type. So notice our method declaration. We have public static, and then we have defined that the return type is going to be string. So what we return will be a string. The method name is phone call, and based on the comment, we understand that we are going to return the phone column of an integer. So on a number pad on a phone with numbers 0 through 9, which column is the number in? So we are going to pass it the number which we want to know the column for, and that's an integer, and we're going to call that number x. So this is a parameter. So make sure you understand this method heading. If you don't, you may need to go back and review some of the method lectures. And then inside this method, we have an if branch which tests if the number is divisible by 3 with a result of 1. So what we're doing here is making use of the periodic nature that we achieve with the mod function. So to make sure what's happening is understood, in a standard phone pad we would have 3 rows and 3 columns of 3. Some weird boxes. And then we have 0, which occurs in the bottom center. Now, if so the number which is on this key is 1 usually. So in this situation, the number modded by 3 would result in a value of 1. Typically, the number in the following key is 2. So 2 modded by 3 would be 2. And then the number in the last column when modded by 3, so 3 modded by 3 would be 0. So 1, 2, 3, this would be 4. When 4 is modded by 3, we have 1. When 5 is modded by 3, we have 2. When 6 is modded by 3, we have 0. So we see here that the number on the key modded by 3 tells us which column we are in, with the farthest left column being column 1, the middle column being column 2, and the farthest right column being column 0. So in our code, we mod the number by 3, and if it is equal to 1, we return left. If this test fails, we still don't know which column we're in. We have to perform a further test. So we test to see if the number modded by 3 is equal to 2, which means we would be in the middle column, or there's another possibility. We could actually have the number 0, right? Because 0 modded by 3 is not 2. So 0 modded by 3 is 0. So in which case we need to explicitly test to see if the number is equal to 0, because it's different. It wouldn't follow this mod rule because it's a weird outlier. So we need an explicit test for that. So if the number modded by 3 is equal to 2, we know we're in the middle column. Or if the number is equal to 0, we're in the middle column. So we would return middle. If we're not in the left and we're not in the middle, we must be in the right. So our if structure here makes sense. Everything that's going on makes sense. It works. And what we are achieving is we are returning exactly one of these values. We will return either left, middle, or right. Okay, and as soon as we hit a return statement, we will immediately jump back to the calling statement. Further, notice that there is no possible way for this code to hit no return statement. Imagine if we had not included the else. So in this situation, we never return right. And we will run into the end of the method down here. And at that point, the program pointer would try to jump back to the calling statement. However, we've not returned a value. We would actually never be able to even run this code. Okay, the compiler actually tests to see if every method is required to return an appropriate value. If there's any program path available which does not return an appropriate value, then the compiler will actually throw a syntax error. So this wouldn't even compile. So our code returns a value along all possible program paths, returns a value of the correct type, and we have ensured that our if structure, our if branching, accomplishes the functionality we desired. Now remember, we said it's acceptable to have multiple return statements. We did not say it was required. And you should know that some companies and some classes may find it better style to have a single return statement in a method. So we could have achieved the same functionality with a single return statement if we had created a string variable and we had initialized that string variable in the if statement, and then returned an expression which was the variable we created. So notice what we're doing. We create this location string, which is going to hold the location of the number. We create that string, then we populate it inside the if statement. Then we return that string as the value. Whatever the contents of that string is, that's returned as the value. So this would be a way of doing this where we didn't actually use multiple return statements, and instead we used a variable, set the value of the variable, and then returned that variable. This is a very common structure. Both of these would be very common and acceptable in this class. So let's do a quick comprehension check. Evaluate this code and see if you understand exactly what's wrong with it. And I'll give a moment for you to look at it before I give you the answer. Let's do another exercise. Pause the video and see if you can figure out which of these two will compile. So the first example is a variation on the program we looked at previously to decide which column a number would be in on a foam pad. So notice the if branch structure. We have if, and we're modding by 3, and if this results in a number equal to 1, then we will return left. Else if, and we have a test, which if this test evaluates to true, we will return middle. And then we have a third test, which is x mod 3 is equal to 0, in which case we are in the right column. So will this compile? No, this will not compile because the compiler recognizes that there's a technical possibility where none of the branches are taken. So consider the possibility where this test is false, this test is false, and this test is false. Then the method will not return a value, in which case this is not legitimate code. So the compiler will detect this and throw a compilation error, a syntax error. Now you may be thinking, but wait, it's actually not possible for all 3 of these tests to fail. It's physically impossible. One of them has to be true. Yes, that is accurate. One of them does have to be true. However, the compiler does not go through and perform a logical test in all possible situations to detect that. All it's basing its decision on is whether or not there is a program path available. Basically, whether or not you used an if structure which left a program path available without consideration of what tests are populated in the if statements. So yes, technically speaking, there is no possible way for all 3 of these tests to fail. However, from the compiler's perspective, without considering the actual nature of each of the underlying tests, it looks at this and sees an if, an else if, and an else if, and it says, well, what if all 3 tests fail? Then we won't return a value, and it will throw a compilation error. So in example B, we have public static, and then we have a return type of Boolean, and our method is named doCompare, and we have one parameter, which is an integer value x. So let's evaluate this to see if it will compile. We have an if statement with x is less than 0, and I see a syntax error right here that will prevent compilation. So this should have been a parentheses, but so that's one error. But let's see if there's any others. So if x is less than 0, then we will return true. Else if x is greater than or equal to 0, we will return false. I mean, makes sense. It seems like what we're doing is comparing to see if it's greater than or less than or equal to 0. So basically doing a check for negativity. But no, this will not compile. Even with fixing the parentheses, this will not compile because yet again, the compiler sees if, else if, and it says, yeah, but what if both tests fail? Both are false. And yes, yet again, this is a physical impossibility for both of these tests to fail, but the compiler doesn't care about whether or not it's possible for both tests to fail based on the variables. All it cares about is available program paths. And it sees how many available program paths? It sees one if this is true. It sees another if this is true. And it sees a third, which is none of them are true. And in the case where none of them are true, we did not return a value. So the compiler would throw a compilation error.